Why is Jupiter called a failed star? It clearly had the potential to be a star, yet it ended up as a planet. What chilling secrets are hidden behind this? Since we were young, we knew that Jupiter is the big brother among the 8 planets of the solar system, with a volume that can hold over 1,300 Earths, and a mass 2.5 times that of the other 7 planets combined. But have you ever wondered why, despite having the same origin as the Sun and almost identical composition, it couldn't become a shining star and instead had to settle as a planet? Today, let's dig into the shattered stellar dreams of this major player in the solar system. First, let me throw out some explosive highlights that will make you exclaim how unbelievable it is. First, Jupiter and the Sun have highly similar compositions, both consisting of 90% hydrogen and 10% helium, which are the standard fuels for a star. Second, it was just one step away from becoming a star. If its mass were 80 times greater, it could ignite hydrogen fusion and become the second sun of the solar system. 3. Even if it didn't meet the standard, Jupiter is not a compliant planet. It generates its own heat and has a magnetic field 14 times stronger than Earth's, possessing many traits typical of stars. 4. If Jupiter really became a star, Earth's fate would be completely rewritten, and we might not even have the chance to exist. Seeing this, are you full of questions? Why can't Jupiter become a star if the composition is the same? What exactly is the threshold for hydrogen nuclear fusion? Is it fortunate or unfortunate for us that Jupiter did not become a sun? Don't worry, let's clarify each point. To understand Jupiter's failure, we must first talk about the birth of stars. Stars in the universe are born from a chaotic cloud of hydrogen and helium gas. Under the influence of gravity, the gas cloud continuously contracts, and the temperature and pressure at the center increase. When the temperature soars above 10 million degrees Celsius and the pressure is great enough to tightly compress hydrogen atoms together, hydrogen nuclear fusion is initiated. This explosion lasts for billions of years, emitting light and heat, and a star officially comes online. Our Sun is a standard example of this. But what about Jupiter? It comes from the same primordial nebula as the Sun, essentially making it a sibling in the solar system. When the solar system was first forming, Jupiter was also desperately accreting surrounding material, trying to increase its mass further. But unfortunately, it was a step too slow. The Sun completed gravitational contraction first, capturing most of the surrounding material. In the end, Jupiter's mass only reached 1,000th of the Sun's, far from the threshold of 80 times Jupiter's mass needed to initiate hydrogen fusion. Here, someone might ask, what about brown dwarfs with 13 times the mass of Jupiter? Aren't they stars? Well, that's another awkward point for Jupiter. Astronomers have found that celestial bodies with masses between 13 and 80 times that of Jupiter can initiate deuterium fusion. Deuterium is an isotope of hydrogen, and such bodies are called brown dwarfs, also known as substellar objects. But the duration of deuterium fusion is particularly short, extinguishing in at most a few million years, and it cannot burn steadily like the Sun. And our Jupiter didn't even reach 13 times the mass, not even touching the threshold of a brown dwarf, and can only honestly be a gas giant planet. To help everyone understand this mass difference more intuitively, let's use a relatable analogy. If the mass of the Sun is compared to a standard basketball, then the mass of Jupiter is only equivalent to a small glass marble. Think about it. How could a small glass marble possibly release as much energy as a basketball? It's like burning firewood. The burning effect of a small twig and a bundle of large logs is vastly different. Although the fuel is the same as the Sun, it's too thinly spread to meet the ignition standard. However, don't think that just because Jupiter hasn't become a star, it's just an ordinary planet. It has quite a star-like presence. First, Jupiter generates its own heat, with an internal temperature reaching 20,000 degrees Celsius, and it radiates energy outward at 1.6 times the energy it absorbs from the Sun. What does this indicate? This indicates that Jupiter is still undergoing slow gravitational contraction, continuously releasing energy, which is a typical feature of the early stages of star formation. Secondly, Jupiter has an extremely strong magnetic field, with a magnetosphere so large that it can encompass Earth's orbit, and the solar wind has to detour when it approaches Jupiter. Finally, Jupiter also has a large family of satellites, with as many as 95 moons orbiting it, resembling a miniature solar system. At this point, the most interesting question arises. If Jupiter really accumulated 80 times its mass and became a second sun, what would happen to our Earth? First, the solar system would change from a single star system to a binary star system. Imagine having two suns in the sky. The scene would be incredibly striking, but despite the spectacle, life on Earth would be tough. The gravitational pull between the two stars would tug at each other, making Earth's orbit extremely unstable, sometimes drawing closer to one sun than the other, with temperatures fluctuating wildly, making it impossible for life to develop. Not to mention, the gravitational pull of two stars could fling the small rocks in the asteroid belt, causing Earth to face intense asteroid impacts, like a disaster movie scene. In this light, it's incredibly fortunate for us that Jupiter didn't become a star. Although it couldn't ignite itself, its massive gravity has become Earth's guardian. Many of the asteroids and comets flying around the solar system are intercepted by Jupiter's gravity, either crashing into Jupiter or being flung to the edge of the solar system, just like the Shoemaker-Levy 9 comet in 1994, which was torn apart by Jupiter's gravity and then crashed into Jupiter's surface. Without Jupiter, this comet might have headed straight for Earth. Speaking of this, do you have a new understanding of Jupiter? It is not a failed star, but a perfectly fitting planet. It almost became the second light illuminating the solar system. But under the arrangement of the universe, it became Earth's most solid support. The wonder of the universe lies in these almost coincidences. Jupiter almost became a star. Earth almost became a furnace. We almost didn't exist today. The existence of every celestial body, the setting of every parameter, seems to be meticulously arranged. Jupiter's failure to become a star is not a regret, but the best gift the universe has given to Earth.
Like, comment, and subscribe.